All right, so we have two cases when we're talking about testing claims about means. One of them is known as matched pairs, and the other is known as independent samples. So we'll do the matched pairs first. But we're focusing on means, which is another name, as should know, for averages. I don't know why I had this up so high to begin with. All right, another name for averages. All right, so we're not talking about percentages anymore. All right, they're usually when we're comparing before and after situations, but they're not just limited to that. We talked about this when we were going over how to design experiments and things like that. When we were talking about simple random samples and stuff along those lines, it's really just an idea that one sample of individuals is collected and two measurements are taken. It's just a question of what those measurements are related to. All right, so my classic example, which I probably mentioned back then, was the left and right-handed dexterity. So you have a task that you want a single individual to do, and you just time how long it takes them to do it with their right hand and how long it takes them to do it with their left hand. Right? And you're just really looking to compare the dominant hand versus the non-dominant hand. Right? So that's an example, but the most classic example is the before and after situations. All right? So independent samples really just comes from two different groups of individuals that really they have a common characteristic, but they're unrelated to one another in some capacity. So if you're talking about performance on a test, maybe you're talking about performance on a test for two different grade levels in a math class. Maybe you're comparing freshmen and sophomores. Maybe you're talking about across different subject areas. So how humanities students perform on a math test versus how math science students perform on a math test, right? So, if you wanted to make a case that math is just a hard class, regardless of what the title is, you can call it statistics, call it calculus, whatever, like math is just hard, then it should be hard for pretty much everyone, even the people who are supposedly math people. And speaking from the perspective of a math person, math is hard. I can tell you that, and I know it. I studied it my whole life. And I'll tell you, it's hard. Why? Because I've had to study it my whole life, right? So, and I can tell you that I understand it more and more every day, even the stuff that I've had to teach for as long as 20 years. So I can honestly say that a new teacher coming in, teaching content for the first time, is not going to have the same in-depth understanding of that material as somebody who's been teaching it for 5, 10, 15, 20. And then me, myself, won't have the same in-depth knowledge of that material as somebody who's been teaching it for even longer, right? So it's an ongoing learning process, right? And so, this is a personal thing, and I don't know if it's related to everybody, but I can say from personal experience that sometimes my best learning happens when I'm explaining a concept, and then the words will come out of my mouth. I'll explain something, I'll be like, oh, that was a good thought. So that's what that means. And so we're all kind of learning the same thing at the same time. All right, so matched pairs is not that situation. Matched pairs is just a simple situation where you're collecting data before and after for a single set of individuals. So that's what we're going to focus on first. So, but honestly, I can tell you that if you're looking in terms of a project, it's probably easier to come up with matched pairs than it is to come up with independent samples, right? Because all you have to do is get a measurement before something happens and a measurement after something happens. What's the traffic situation before 9 a.m. and what's the traffic situation after 9 a.m.? You would just have to determine a way to come up with a measure for the traffic situation, but you could be talking about number of cars that pass a person standing at an intersection in a 2-minute period. Right? That gives you a sense of volume. Right? So you do that before 9 a.m. and you do it after 9 a.m. and you see what the story is. So match pair is pretty easy. To come up with two different samples of individuals involving traffic, I'd really have to think about it, but off the top of my head, I can't come up with anything. because all the drivers they have something in common. They're usually in a rush to get somewhere, so how do you break them down? I mean, I know how we break them down. Audi drivers and everybody who's not an Audi driver. But aside from that, like really, how is it gonna work out? I don't know. So null and alternative hypotheses are going to work pretty much the same way as it did for the population proportions, except we're using mu's instead of p's. But the alpha value, how the p-value works, how we state the conclusion, that's all the same. All right? And surprisingly, there isn't a unique test in our calculator for this. It's a t-test. All right? We've used this before. But this time we're gonna use it a little bit differently. So the calculator approach is more involved than the previous tests were. All right. Not to say it's more difficult. It's just you got to do more things in your calculator. But I always look at that as that's better than the alternative, because more things to do in the calculator means less things that you would have to do by hand. All right. So the question says to use a 0.05 significance level to test the claim that there is no significant difference, so we'll have to think about what that means, between the average New York Giants winning percentage before and after a bye week. Doesn't matter what a bye week is. The key is that it's before and after. You see before and after in a board problem, you know it's matched pairs. Between the 1996 and 2004 seasons. All right. The motivation behind this had to do with the Giants were a terrible team at that time. They're a terrible team now. Not that, I mean, you could insert your favorite hobby in here. Your favorite TV show. Oh, it used to be great. Now it sucks. All right. Maybe you don't like football, maybe you like soccer. Your team used to be great, now it sucks. Like whatever used to be great, now it sucks. Right? That's what we're talking about, and that's what happened here. All right. So alpha is 0.05. People used to be nice, now they suck. Right? So I don't know about that one, but maybe it's the other way around. I don't know. Yeah, I think it is true, though, actually. I think people are just generally not nice anymore. So anyway, maybe somebody could do a study on that. Prove me wrong. I'd like to be proved wrong about that one, because I need to have some hope for society that people will actually just generally be nice to one another. The number of people, now, like, I'm not trying to be like, I don't know if the word is chivalrous or whatever, but like holding the door for somebody, like I think that goes like that crosses gender lines. I don't think it doesn't matter. You hold the door for somebody. It really doesn't matter for somebody. But a number of people, like at Dunkin' Donuts, that I've held the door for, that they've said, "Nah, don't worry about it." And I'm like, "What do you mean, don't worry about it? You're like 2 steps away. Get through the door. I'm holding it for you. What's wrong with you? Go."
They feel bad about themselves that they can't come to that level of good.
I appreciate it.
Sometimes I'm like, don't worry about it, because I don't feel like
You don't
moving
have
any
it in
faster,
there.
and then I feel bad that you.
And I'm happy to wait.
It's not about you, it's about me.
Yeah, but
But usually with somebody holding the door for you, you're a couple of steps away, you actually go a little faster.
yeah,
I
You
just
know,
tell them,
appreciate that you're doing it, thank you.
yeah, generally.
Yeah.
There's that part of it. There's a social aspect to it.
They're just resentful.
But like, maybe there's a better way to handle it. Like, I can't move any faster. You know what one person said to me, because my back was killing me one day, and I have friends that follow the 3-second rule. Like, if you're more than 3 seconds away from the door, there's no holding the door. Like, they just go, But this person held the door for me, and I was like a country mile away. And I was like, all right, I'm a-coming. But my back was killing me, my knees were killing me, like everything was like locked up, and I was like, I'm coming. They're like, move, come on, you can do it. I'm like, shut up, I'm trying. So like there's exceptions to everything, I think, but like the niceties have somewhat fallen off. But I got someone on Monday with that one when they were like, no, it's fine. And I was like, no, I'm holding it. It's fine. Take your time, though. And then when they came out, I was like, I just want to start the week off on the right foot. And they were like, oh, well, that was nice. And I was like, now we both start the week off on the right foot. So we can all smile on our way to work. That generally is probably going to suck for both of us. So.
I hope Toby won't feel home. I would say the majority of people out there still home.
Okay. So that would be the hypothesis. P is greater than 0.5, and so maybe somebody wants to run a study on that. And that one I think is kind of hard to orchestrate because I have students in my high school class that they're running a study on whether people will, because it's also a social experiment. If you drop something, what percentage of people will pick up that something and return it to you, right? One of the students in their group was going about it the wrong way because he was sort of hamming it up. And he's like, whoa! And then he would drop his keys. And people would be like, all right, you just did that on purpose. Like, I'm not picking your keys up for you. But the ones who did it correctly, they as they were walking, it would just slip out of their hands. And then somebody would either come up to them with their key. And they were doing it with their car keys. So they're taking chances. But they were doing it with their car keys. And people generally would either do one of two things. Yo, you dropped your keys, or which is good enough. I mean, you don't have to pick up my keys for me. You know, like a little heads up that I just dropped them, even though I probably should have noticed when I heard the clank on the ground. Or in a lot of other cases, they would actually pick up the keys and return it to the person. So that they haven't had any instance where somebody tried to pick up the keys and run away with them. So far, so good. But they'll be out of a car if that happens. So I don't know if that's probably the best way to go. But, little studies, all related to percentages, right? So how that ties into averages, well, this is an example because what I did was I took a situation that typically relies on percentages, winning percentages, and I made it into a case that involves averages. Percentage per year over a course of a certain number of years. And now what I'm looking for is the average percentage, all right? So the average winning percentage. So I combined the two ideas so that I could use matched pairs, all right? So what I'm looking for is no significant difference between the two data sets. Now, no significant difference. That means that the means are equal. All right. If there's no difference between two numbers, that means those two numbers are the same. All right. So that's actually giving me my null hypothesis. Now this is the first instance where we're faced with a situation where the question itself does not just flat out tell us the alternative hypothesis and ask us to make a conclusion based off of it. So now it's the question of, well, what would be the alternative hypothesis? Well, we have to have an alternative hypothesis, otherwise the calculator is not going to know what to do. So we know it's going to have the same ingredients, mu1, mu2. But I don't know, is it going to be more than or is it going to be less than, right? Because our possibilities usually have fallen down to, oh, it's greater than or less than. If I don't know, then it's either greater than or less than, all right? Which means that it would just simply be not equal, all right? So not equal means you don't know if it's greater than or less than. I'm saying that now because it's going to take me forever to write that. You don't know if it's greater than or less than. And it is the alternative hypothesis. So you don't know if the alternative hypothesis is greater than or less than. I wonder if this is like what it was like back in the day when you had to write with a fountain pen with the ink and...
So you said you don't know if the alternative hypothesis is greater or lesser than?
greater than or less than, yep. I'm getting there. Oh, one sentence and I already got writer's cramp. All right, so that's what our default is. Like, I don't know. I don't have any information based on the research. Like, the data may bear out one way or the other as greater than or less than, but I don't know that until I start evaluating the data. But based on the question itself, without looking at any of the data, if they say no significant difference, that means equals. Well, what's my alternative? Well, just not equal, because they haven't told me anything else. All right. So now what we're going to do is we're going to put this information in our calculators. We're going to take the before values and put that in L1. And the after values, we're going to put that in L2. There's another way to do it, but this is the easier way, which people tend to find surprising once they see what we're about to do. I don't know where to put this because there's no good place. Oh, I'll have to move it as we go. Stat edit. Oh, you know what? I was doing it the other way, so let me just do it this way. So again, it's going right in the calculator, L1 and L2. And we're just double checking down the line to make sure we didn't type it in incorrectly. So once you do that, now what we're going to do is just quit out of here. So second mode. So you're in the home screen. Second mode. And then we're going to hit stat test 2. So stat test 2. So over to test, option 2, number 2. All right, once you select that one, you see when we did this, the t-test before, we had an option for data or stats. And I mentioned that the only time you would select data is if you had typed in data, right? Data as in a raw list of data, which is what we just did. Now previously, what we did was we typed in statistics. summary statistics, because the problem gave us a mean, it gave us a standard deviation, it gave us a bunch of things, right? And this, I don't even think was from the problem we did. Another teacher was in here. But what we want to do is we want to write left arrow over to data and select that one. So over to data and hit enter. All right. Then your mu sub 0 should be equal to 0. Now, you'll see here that we only have one list available. So we have a little bit of an issue here, right? Because, well, yeah.
I'm missing the list on mine.
Did you hit enter on data?
Okay.
No problem. So it only asks us for one list, but we put data in 2 lists. All right, so we're going to ignore that for a second and go down to our alternative hypothesis, because that's one thing we do know. We know that that's supposed to be a not equal. Now there's a way to handle this in the list editor, but as I was talking about before, sometimes I'll learn something with students. I've actually never tried this before, so I don't know if it's going to work, but it'd be great if it worked, and it would undo the way I've been teaching this for the last 15 years. It's dangerous. No, it's not going to work. Okay. I was kind of rooting against it anyway, because I would have felt like a fraud. All right, so what we need is a list that represents these 2 data values all in one shot. So what we're going to do is we're going to make this list 3, L3. All right, so second 3. And you might say, well, we didn't put anything in L3. Well, we're about to. And then we'll come back to this. But sometimes it isn't until you get to this where you realize that you need to make an adjustment to your data. All right? All right, so that's going to be the setup for the t-test specifically for matched pairs.
Mu sub 0 equals 0. Does that automatically come up, or do you have to enter that?
You have to enter that.
Okay.
So this is our setup for matched pairs.
I'm sorry, I can't see much from here. Is it list L3 or L2?
L3. All right, so we're going to quit out of here again and go back into the stat editor. Now, when you do this on your own, you'll do everything in the stat editor all in one shot. I just wanted to give you the setup, because what you're going to write on your index card, or in your notes, sorry, is this is your setup for matched pairs. So when you go into stat test 2, you're going to want to make sure that you know that this is how the setup ought to be. All right, the only difference might be your mu could possibly be less than or greater than, depending on how the problem is stated. All right, so let's go back into the editor. So second mode is quit. Then stat edit. And like I said, this normally we would do in one shot, but for this first time, we're kind of bouncing back and forth. All right, so this is the weird, unique step, because normally it's just going to the stat test menu, hit a few buttons, and then go to calculate, get the p-value, and call it a day. Here, what we have to do is hit enter on L3. All right, so you're hitting enter right on that column heading L3. So what that does in the bottom of the screen, it gives you a field where you could put an operation. All right, that operation is going to be between L1 and L2. So what we're going to do is we're going to subtract, we're going to write L1 minus L2. So you hit enter on the column heading L3 and then type in L1 minus L2. So second 1 minus second 2. So enter on the column heading L3 brings you to the bottom field. Then you're typing in L1 minus L2, which is second 1 minus second 2.
Now we're using that minus for the bottom.
Sorry?
The minus, keep the very bottom one that's in
This
minus sign.
the regular minus sign, not the negative sign. And once you do that, you can hit enter. And it's going to create a list of differences in L3. All right, so each one of these values represents the difference between L1 and L2. So if I did L1 minus L2, I would get this entry in L3. All right, so it saves us from having to do those calculations by hand. And this is yet another one of those situations where back in the day, when I didn't know that the calculator did all this stuff, I'd be like, well, all right, let's subtract all the values. And it was fun, except it wasn't. Also back in the day when we never finished the course either. You're bogged down with all the... You got an error? All right, so I'm going to walk through the process one more time because it's not uncommon for people to get error the first time. So there's a pretty common flaw that happens. All right, so when you go into the list 3, it by default puts you in the first cell. You don't want to be in the first cell. All right, so if you hit enter here at the bottom of the screen, it's going to say L3 of 1 equals. We don't want that. All right, what you want to do is go on to the column heading L3 and hit enter. And then type in L1 minus L2.
Oh.
And then it'll do it. All right. Now, if you know you did that and you still get an error, the most common reason why is because there's usually a mismatch between L1 and L2. So if you know that you did everything correctly in L3 and you still got an error, it's usually because you have an unequal amount of values in L1 and L2. So probably 10 values here but 9 values there, something like that. Right, because the calculator gets really confused when it doesn't. You're telling it to subtract 2 numbers and you didn't give it 2 numbers to subtract. All right. So we'll quit out of here again and go back into stat test, option 2. So the menu's still the same as before, but now it's referencing list 3, which is a meaningful list 3. All right. So when you're doing this on your own, you're doing this stuff all in one shot. All right. So you're going from inputting the data to manipulating L3 to then doing your stat tests. All right. So I could even, this one actually, I guess I don't even need to have there anymore. It's going to be more like this. All right, so now when we run our calculations here, it'll come down to interpretation. All right, but that's always the case. So you hit enter on calculate and you get the results of the t-test. You get a p-value. And again, all we care about is the p-value. That is a jumbo highlighter. A little bit better. I'll do it twice to make it look right, though. All right, so We got a p-value of 0.45-ish. All right. The alpha value is 0.05. So the p-value, in order to reject the null hypothesis, the p-value has to be less than alpha. All right. So p-value.
Yeah, no, it's
Higher than yours.
Okay.
Me too, but I'm wondering if it's because under mu I didn't select not equal.
That's usually what the reason is. If you did everything else the same, the most common error is right here.
Okay. That's it.
So try that again in the stat test.
And you have to be 0.
And it also has to be 0.
What has to be zero?
Mu. Or,
So those would be the two easier fixes. If it's not one of those, then unfortunately it means you got to go back into L1 and L2 and
Oh, I got it.
okay. Yeah, in these situations, you don't want the mistake to be data entry, because those suck. Because then it's like, then it becomes an eye test. Or like, I mean, the number of times that people have shown me calculators that they swear the data has been entered correctly, and then I see that they typed in their .364 as .346, and I'm like, there it is. They're like, but I looked at it 300 times. And I looked at it the 301st time, and I found it. So that's what happens. And actually, the reality is I just looked at it the first time with fresh eyes, and I could pick it up a little easier. You know, so can't find my own mistakes, as you've been able to tell with all the typos in the packet, but I can find everybody else's. All right. So the p-value is not less than alpha, so we do not reject the null hypothesis. So we do not reject the null hypothesis, which means we're keeping the null hypothesis, and the alternative is the one that's being ditched. But if you remember, the alternative is one that we invented just to make the calculator process work. The question was only asking us about the null hypothesis. Right? So when we write our conclusion, it's going to be a more streamlined version of what we would normally write. All right? So let me clean this up a little bit. I don't know why it makes it so huge. And I can't even find where to shrink it. Oh, there it is. There we go. All right. So there is insufficient evidence to reject the claim that, this one's an easier one to write because we're just pulling the words right from the question, that there is, and I'll highlight it up here. I think my normal highlighter will work for this. It's a little chunkier. You don't have to go too crazy with it, and you could paraphrase, but you do have to get the important ingredients in there. And the reality is, since the words are already there, it really just, I mean, there might be a little huffing and puffing of, do I really have to write this? But you're just rewriting. It's not like their original thoughts, you know, you're just writing, you're just reproducing something that's already written. There is no significant difference between, and it's especially important for situations like this, where not everybody is familiar with NFL football. So there's a good chunk of people that wouldn't even know how to phrase a sentence like this contextually, all right? Just like I wouldn't necessarily know how to phrase a sentence contextually if it was talking about organic food versus not organic food. I don't know. I just know that one has better sell-by dates. Like if I buy organic milk, the sell-by date, if I went to the supermarket now, would be sometime in like late January or early February. Whereas if I got the one that is not organic, that it would be like sometime in like 3 weeks. So if I'm gonna pay $6.99 for a gallon of milk that's gonna expire in like 3 weeks, why not pay the extra $1 and get the one that'll expire in like 2.5 months, right? But that's the extent of my knowledge of organic food. All right, winning percentage before and after a bye week. We don't have to worry about the years. At the 0.05 level. So I'm going to highlight this in red. Text color red. Now the second sentence, normally we'd write a second sentence, the therefore sentence, but in this case it's irrelevant because that second sentence would be addressing the alternative hypothesis. But like I said before, we only came up with that on our own to make the hypothesis test work in the calculator. The question wasn't asking us about that. All right, so if we don't include that, that's expected. If we did include it, that's okay too. Like if you wrote, therefore, therefore, the claim that there is a significant difference is false, I would look at it and say, okay, I don't know who is claiming that, but you're right. Like that claim is false. All right, but nobody claimed that. But yeah, it's false. So good. So if somebody comes around claiming that, I'll know what to say. All right, irrelevant, but not incorrect. So you're fine. All right. So what most people do is they write the two sentences, the complete template, regardless of the situation, because they know they can't go wrong that way. But in this particular situation, because the question was only asking about the null hypothesis, and the first sentence of the conclusion addresses the null hypothesis, that's all you really needed. Right, so that was page 55. Oh, that's not what I wanted. Alternate shift Q. No. Window shift